Suppose a trailer can carry a maximum weight of 160 pounds and a max volume of 15 cubic feet. If a microwave oven weighs 30 pounds and has 2 cubic feet of volume, and a printer weighs 20 pounds and has 3 cubic feet of space, write a system of inequalities to model this situation and graph the system, and then use that to answer a couple of questions. So let's let X represent the number of microwaves that we have, and Y be the number of printers. So we can write one inequality that has to do with weight and one that has to do with volume. So thinking first about the weights, if you take the number of microwaves times the weight of each microwave, we'll have 30x. Plus, then for our printers, we'll have 20y. We need to make sure that's less than or equal to 160 pounds. So then for our volume, we'll have 2x, 2 cubic feet for each microwave, plus 3y. We need that to be less than or equal to 15. Since our x and y represent actual objects, it would also be true that x needs to be greater than or equal to 0, and y needs to be greater than or equal to 0, because you can't have a negative number of microwaves or printers. So let's look at how we could graph each one of these inequalities. So I'm going to start by solving for y to make it easier to graph. So subtracting 30x, here I have 20y is less than or equal to negative 30x plus 160. And then I'm going to divide everything by 20. So I have negative 3 halves x plus 8. And then here, same idea, I'm going to subtract my 2x. So I have negative 2x plus 15, and dividing by 3, y is less than or equal to negative 2/3 x plus 5. So I'm going to graph each one of these lines and think about my shading. Less than is going to make my shading go below my lines. So here, starting at positive 8, for a slope of negative 3 halves, I'm going to go down 3 and right 2, down 3, right 2, down 3, and right 2. I'm going to connect those with a solid line. This option. Then I'll do this one in a different color just so we can see it. Negative 2/3 x plus 5. I'm going to start at 5, go down 2, and right 3, down 2, right 3, down 2, and right 3. So again, a solid line. These. And then if you think about our inequalities, x is greater than or equal to 0, y is greater than or equal to 0. X equal to 0 would be the vertical line that is our vertical axis. Y equals 0 would be the horizontal line. That's our x-axis. So think about where this shading needs to be. We know that we need to be x is greater than or equal to 0, so it's going to be on the positive side of our y-axis and the positive side of our x-axis. And for each of our other inequalities, we needed to be less than or below that line. And so if you can picture this as kind of trapping an area or enclosing an area, our solution set is going to be this region in between what is now those 4 lines. So that's where you have x's that are greater than 0, y's that are greater than 0, and where y is less than or equal to negative 3 of x plus 8, and also less than or equal to negative 2/3 x plus 5. So any point in that shaded region, the yellow region, represents a combination of printers and microwaves that we can carry on this particular trailer. So if we come back to then the questions in part C and part D, in part C we have 4 microwaves, so that would be x equals 4, and 2 printers, so y equals 2. So we could look at plugging those values into each one of our inequalities and make sure it gives us a true statement. Graphically, you can also think of that as the point 4, 2, which would be this point right here. So it's right on our boundary, but it is part of our solution region. If we look at plugging each of those in, we'd have 30 times 4 plus 20 times 2. We want to make sure that's less than or equal to 160. But then we would also have 2 times 4 plus 3 times 2, make sure that's less than or equal to 15. So we have 120 plus 40, we have 160 is less than or equal to 160. Equals is an option, so that checks out. And here we have 8 plus 6, so we have 14 is less than or equal to 15. So that one checks out as well. So we would say that, yes, you can carry 4 microwaves and 2 printers on the trailer. So our last situation then, what about if x equals 7 and y equals 3? So graphically, if we find the point 7, 3, notice that that is outside of our shaded region, so it's not in our list of possible ordered pairs that are shaded by our yellow shading. If we go to plug it in, so 30 times 7 plus 20 times 3, we have 120 plus, or 210 plus 60, and so we have 270 is less than or equal to 210, which is a false statement. So we don't even need to check it in the second inequality because it failed on the first. It doesn't matter whether or not it works for the second. So writing a system of inequalities means we're determining what our variables represent. So here, number of microwaves and number of printers. And then using those x and y definitions, we can write one equation that goes with our number of pounds and one that goes with our cubic feet of volume, and keeping in mind that x and y also need to be positive values because of our situation. We can graph each of those inequalities, and then the shading represents the region of solutions here. We can then check particular values for x and y by plugging in. To be a solution or a possible situation that would actually work, it needs to satisfy both inequalities. If it fails in one or both, then we would say that that is not a solution to our system of inequalities.